We've done the area of several different figures, parallelograms, triangles, circles, trapezoids, all sorts of things. But what if they put more than one of them together? Oh, why would they do such a thing? Well, because in the real world, lots of things aren't just one simple shape. They are multiple shapes, or they're close to being multiple shapes anyway. So a composite figure, composite, same root word as compose. So just like composing music can mean putting instruments together, putting notes together, making music by putting things together. And composing can also be talking about making something or putting things together. So anyway, a composite figure is made up of two or more shapes. To find the area of the composite figure, break down the figure into shapes whose areas you know how to find. Find the area of each shape, then add them together. So here's the steps I want us to follow as we go through each of these. Determine what shapes make up the figure. Determine the dimensions of each shape. That could be a base, a height, a length, a width, a radius. Then find the area of each shape and add the area of each shape together. So here's our first example. So our shapes. This is a parallelogram, which is area equals base times height. The base is given to us right up here. That's our base. And over here is our height. So those are the pieces we need for the parallelogram. The base is 17. The height is 9. If you multiply those together, you get 153 square feet. So that's the area of the parallelogram. Now this is a triangle. Formula for a triangle is half times the base times the height. The base of this triangle is the 8 right here, and the height is the 10. So we'll do 1/2 times the base times the height. We multiply those together and we get 40 square feet. So we've found the individual parts just the way we've done it all along in chapter 11. So to find the composite of these two put together, we simply add them together. So 153 plus 40 means this shape as a composite as a whole is 193 square feet. Okay, number 2. We have a half circle and a triangle. So for the half circle, the formula would be half times pi r squared. So the only dimension we need for the half circle is its radius. Well, right here, this would represent the diameter of the circle. So we need the radius, which would be 3 millimeters. So the radius is 3 millimeters. So 1/2 times pi times 3 squared. And we'll just say that's approximately 14.2 square millimeters. Triangle is half times base times height. The base of this triangle is the 6 millimeters right here. The height is the 16. Because you can almost think about like the triangles this way. So that's its base. This is its height. So half times the base of 6 times the height of 16 gives us 48 square millimeters. So our final step is to add these two together to find out that the composite figure is 62.2 square millimeters. Yes, you see my writing. It's the back of the page. It's true, it's common. I'm not alone in this. It's common in math books too. The farther you go, the harder things get. But, well, sometimes the problem doesn't directly give you all the dimensions that you need. But the good news is all it takes to get you what you need is a little bit of adding or subtracting. So you'll see what I mean in just a moment. So this time we have a rectangle and a triangle. So let's start with the rectangle. We usually call that length times width. So I'll just say the length is 23 and the width is 15. You could also call that base and height if you wanted to. It would work out either way. So for the rectangle, we do 23 times 15, which is 345 square inches. Then for the triangle, the formula is half times base times height. So here's where the trouble is. The height we have right there, that's easy. The height is just the 8 inches, because you kind of got to think of the triangle this way. So this is the base. The base is the distance from here to here. Well, they told us this piece from the dot to this line is 6 inches. This piece from the dot to the line to the dot is 6 inches. And this piece in the middle, we actually have that right here. It's 15 inches. So for us to figure out the measurement of this base of the triangle, we'll have to add these three numbers together, because they three together make up the base. So 6 plus 6 is 12. 12 plus 15 is 27. So our base is 27. Our height is 8. So while they didn't explicitly say the base is 27 inches, they did give us enough information to add those things together and find that. When you multiply those, you get 108 square inches. So we now have the area of the rectangle and the triangle individually. So to get the area of this arrow shape, we just add these two together. 345 plus 108 gives us 453 square inches. Okay, next up, we have almost what looks like an L shape. So this one, as far as splitting it up, you really have two choices, and either one is completely fine. We could draw a line right here, and then basically take this as the big vertical one, and this is the horizontal one, and find that area. Or we could draw a line right here and make the whole bottom one shape, and then this sitting on top of it. It'll work fine either way. I'm just going to choose to draw a line right here. And these are both rectangles. We'll just call this rectangle 1 and this rectangle 2. Okay, so for rectangle 1, here's where we've got to be careful with our dimensions. We know the area is length times width, or base times height, whichever you want to call it. So the width, I'd say, is right there. It's the 3 feet. Or you could say that's the length. It doesn't matter which one you call which. I'll just call that the width. But we've got to figure out the distance from here all the way down to here. Now we know from the dot that I drew to where these two shapes meet is 5 feet. And then we can use this piece of information right here to figure out the rest of it is 3 feet. So put together, that is a length of 8 feet. 5 plus 3 is 8. So we do 8 for the length and 3 for the width. Multiply those two together and we get 24 square feet. So that is the area of the first rectangle, the one that's upright, or the one that's more vertically oriented. Now for this one, rectangle 2, also do length times width. Okay, this time you could say we have the length, it's 3 feet, but we only need the distance from here to here. This 10 feet is the distance from this all the way to this side, but we don't want to go that far because this part is already covered in the first rectangle we did. So here we have to consider that if this whole thing is 10 feet, and we can see from up here, this piece is 3 feet, we know 3 feet plus this amount, or this length, has to add up to 10 feet. So it's 3 plus what equals 10 feet. You just subtract 3 from both sides and see that that would be 7 feet right there. So it has 7 feet as its width and 3 as its length. So 3 times 7. So we had to subtract on this one because we were told this whole bottom line is 10 feet long. This portion is 3 feet. So we subtract 10 minus 3 and get 7 feet right there. So that gives us 21 square feet for that particular rectangle. Add 24 and 21, we get a total of 45 square feet. Last one. Okay, here we actually have 3 shapes technically. So if I just draw a line right here, then I have a trapezoid. Draw another line right here, I have another trapezoid. And one thing you might notice is this shape is symmetric. You could turn it this way and think about it this way. It's symmetric about this line right here in the middle. So those trapezoids are actually identical. So if I find the area of one, then I can just put that in for the area of the other. So I've got a trapezoid here and here, then a rectangle here. So let's do the trapezoid first. Sorry, got lost in my train of thought. For the trapezoid, we have half times the height plus base 1 times base 1 plus base 2. Okay, the height of the trapezoid is right here. It's the 5 feet. And okay, base 1, if we call base 1 the bottom, you see right here, it says 18 feet covers this whole thing. So that's why they got these lines drawn to make sure you know 18 feet is not the top part, it's what would be the bottom of the trapezoid. So we'll call that base 1. And it's actually all the way down here, they tell us the distance of what up here is kind of the top piece, and that's 10 feet. So we've got one of the bases here, 18 feet, the other base here, 10 feet. So we get 1/2 times 5, 18 plus 10 is 28. And when you multiply all those together, you get 70 square feet. So remember, that's the area for both this trapezoid up here and this trapezoid down here, because they're identical, they're congruent. So if I find the area of one, I have found the area of both of them. So now we'll do the area of the rectangle. Okay, so the area of the rectangle, length times width. Okay, so the width would be 18 feet because it's the same as the base of that trapezoid. And then the width, or length and width, I don't know, I like base and height better. Anyway, 20 would be the other measurement we need. So we do 18 times 20, and that gives us 360 square feet. So we need to add 70 twice, because 70 shows up here and here. You could also say 2 times 70 if you wanted to, plus the 360 to cover the rectangle. So we got 3 numbers because we have 3 shapes this time. And in total, we get that composite figure is 500 square feet.